Hello everybody, Hobo here, and today we will be talking about the product to sum formulas. So we will be asking the questions if we have the three functions, sine A cosine B, sine A sine B, and cosine A cosine B. Can we rewrite each of these three functions into a different, perhaps simpler format? And the answer to that question is yes, we can. So today, I will discuss the simpler expansion. So let us begin with expanding sine A cosine B. Now, if we recall correctly, the sine of A plus B is equal to sine A cos B plus cos A sine B. So then we can extract sine A cos B, and sine A cos B is equal to, let me just call this A. So sine A cos B is equal to sine of A plus B minus cosine A sine B. Now we want to simplify this further, so we introduce the expansion sine of A minus B. And we do this because if we use this same expansion, and if we isolate cosine A sine B, and we try to use it in here, then we get cosine A sine B is equal to sine of A plus B minus sine A cos B. And because it's minus, that becomes sine A plus sine A cos B minus sine of A plus B. And minus sine of A plus B cancels out with sine of A plus B. And then you simply get sine A cos B is equal to sine A cos B, which proves nothing. It's tautological. So we will be introducing this, which is sine of A minus B. And if we remember correctly, sine of A minus B is equal to sine A cos B minus cos A sine B. So then we can isolate negative cos A sine B, and that just equals sine A minus B minus sine A cosine B is equal to cos A sine B. So then we can use that, negative cos A sine B. So then we can plug this into there, and then we simply get sine A plus B plus sine A minus B minus sine A cos B. So then we can bring back our sine A cos B. We can add, and then we get 2 sine A cos B is equal to sine of A plus B plus sine of A minus B. And then all we must do is divide by 2, and then we have our final product to sum formula of sine A cos B. Now that we've finished that, we will move on to cosine A cosine B. So we will ask the question, cosine A cosine B, can it be expanded into a simpler format? And yes, we can, because this looks very familiar. It is cosine of A plus B is equal to cos A cos B minus sine A sine B. So we can add this term here, and we get cos A cos B is equal to cos A plus B plus sine A sine B. And just like we did in the last function, we would like to expand this term over here. So the way we expand this is we introduce cosine of A minus B, because as we saw, introducing the same expansion twice will lead to a tautological result. So what we would like to do is introduce cosine of A minus B, and this is equal to cosine A cosine B plus sine A sine B. Now, we wish to isolate sine A sine B, so we can subtract by Kosei Cos B, and then we get sine A sine B is equal to cos of A minus B minus Kosei Cos B. And then we plug that in for sine A sine B, and we have cos of A minus B minus Kosei Cos B. And then we can simply add on this side, and that gives us 2 Kosei Cos B is equal to cos of A plus B plus cos of A minus B. And then all we must do is divide by 2 again, and we have our final expansion for Kosei Cos B, which is cos of A plus B plus cos of A minus B divided by 2. And we shall talk about our final case, which is the expansion of sine A sine B. So sine A sine B is also slightly familiar to us because it appears in the cosine of A plus B expansion. So cosine of A plus B is equal to Kosei Cos B minus sine A sine B. So we can isolate the sine A sine B, bring it over here, bring cos of A plus B over there, and we have sine A sine B is equal to Kosei Cos B minus the cosine of A plus B. And then we can use that, we can use that, and all we must do is expand this term over here, cos of A cos of B, and if we do that, we use cosine of A minus B, and this is equal to cos A cos B plus sine A sine B. And we wish to isolate Kosei Cos B, so that simply then is cos of A minus B minus sine A sine B is equal to cos of A cos of B. So then we can plug this in to our original function, and we have we replace cosine A cosine B with cosine of A minus B minus sine A sine B. And then we have sine A sine B is equal to cos A minus B minus cos A plus B minus sine A sine B. Then we add, and then we have 2 sine A sine B is equal to cos of A minus B minus cos of A plus B. And then all we must do is divide by 2, and then we have our final expansion for sine A sine B, which is cos of A minus B minus cosine of A plus B, all divided by 2. And this final formula concludes the 3 formulas the three product to sum formulas of trigonometric functions. Thank you very much.